Hey everyone, how's it going? Uh, so long time no see. Um, the Garfield's totally in the way. I'll probably move him for next time, but for now, it's festive. Okay. What we're going to be looking at today is we're going to be going through a couple of examples of writing equations based upon chemical descriptions of chemical reactions. These are both examples are going to be from the back side of your homework. The homework is due Thursday. I'm also going to show you how to directly type this into the homework as well. If you have any questions, don't hesitate to email me, drop a line in the classroom, or show up in Discord. I'll be around. Ask questions. Yeah, I'd love to hear from you. So, without further ado, let's move over to here. So, what we're going to be doing is we're going to be looking at these two, the number 1 and 2 from part 2 on your worksheet. We'll do them together. All right. So there's not a ton here that's totally new. The only new thing are states. And what I mean by states are, well, things we've always covered. Solids. Let's see if I can type quick today. Solids, liquid, gas, or dissolved in water is its own as well. So we use different symbols for these. So if something's a solid, we just tell everyone it's a solid by putting a little S in parentheses. If something's a liquid, you put a little L in parentheses. Traditionally, that is a cursive L for whatever reason. Gas, little g. And here's the new one. It freaks people out, but the Latin word we use for this is called aqueous. So something dissolved in water, we say that it's aqueous. So aqueous has the symbol AQ. So this AQ tells people, oh yeah, this thing is dissolved in water. So let's look at this reaction right here and see if we can tell what's going on. So nitric oxide reacts with ozone to produce nitrogen dioxide and oxygen gas. These reactions always work the same way, is we're going to have some arrow, and on one side of the arrow, oh, that's a horrible arrow. We have some arrow, and on one side of the arrow, we are going to draw our reactants, and on the other side, we're going to do our products. And it's laid out pretty nicely here. Now, some of the reactions will be a little bit more tricky, but these two are laid out fairly nicely. So our two reactants, they're kind of told to us here in the sentence, nitric oxide and ozone. So nitric oxide and ozone. We're given the formulas for both of those, so we don't have to worry about what the formulas are. Not so lucky on the other side. On the other side, we know we have nitrogen dioxide. Nitrogen's N and oxygen's O, and this has a di, which means we must have two O's. So NO2. Second, the oxygen gas here, well, the symbol for oxygen's O. Is that it? Just O? Okay, that was a trick question, right? Right? Yeah, it's a Hofbrinkel. Good, I'm glad you got that. Thank you. Because you got that it was a Hofbrinkel, right? Hofbrincl. Those are all Hofbrinkels, which means it's not O, it's O2. So the NO and the O3 are reactants. The NO2 and the O2 are our products. So I'm going to go ahead and put little plus signs in here to say, yeah, we're putting together these two things, and we're making these two things. Now, we do need to put the states of matter here. Now, we are told that oxygen's a gas. So I'll go ahead and put oxygen here as a gas. The NO2 is implied to be a gas as well. Now, I will not make you memorize what states of matter most things are. I'll usually give you enough information to figure it out for yourself, or there'll be quite a bit of leeway. Now, some of these things, like ozone, you might have heard of before, and you might know that ozone is a gas. And if you do, please tell me, oh yeah, ozone, it's a gas. You might not know that. So if I don't give you the information in the problem or enough information where you can make a reasonable assumption, feel free to just give your best guess. So the nitric oxide, they don't tell us what the state is, but the rest of these are gases. I'm pretty sure that's a gas. We do have to balance this, but as far as balancing goes, balancing in this problem is pretty easy. Here's a look. I have one nitrogen here and one nitrogen here. And then look, I have one oxygen here and three oxygens there. That's four altogether. I've got two oxygens here and two oxygens there. That's four altogether. So look, I have the same on both sides. I believe that this is balanced. Yeah, done. Wonderful. Here, let me now show you how to type that into the worksheet. So I am going to expect you to turn this worksheet into me. When you do, you might need to do some typing. So let's show you how to do that. So here's your actual worksheet. You can just type this directly into here. So first, I'm just going to type it without using anything too special. I'll point out a couple little tricks along the way that'll help out. But let's go ahead and start this off. Nitric oxide, NO, and we said it was a gas. It's going to react with ozone. Now I'm just going to type O3 for the time being. Nothing too special here. I'm going to zoom in, make it a little bit easier to see. It's just a gas. I'm not going to mess with that 3 yet. I will in the future, but for right now, we'll leave the 3 normal. All right, now here's the first thing that might be nice for you to know. If you do dash dash greater sign with an arrow and then space, it automatically turns that into a normal arrow. Then we know this is going to make NO2 and O2. All right, so far so good, but I do want to make those numbers subscript. So to make a number subscript, it's pretty easy. I'm using the arrow keys. Way easier to use the arrow keys than to use a mouse. So go ahead, use the arrow keys, go to the number, hold shift, and highlight that. Highlight the number, and then control comma. Arrow over to this next 2, highlight it with shift, control comma. Arrow over to this 3, highlight with shift, control comma. That's it. It's done. So we've now entered it into our worksheet, and that's the way I want to see it. Now, as you're going through this worksheet, you can just type directly into it, and then with these pictures, feel free to actually draw into these pictures using our Google Drawing tools. You know how that one works. We've done that before many a time. Did I break the... Uh-oh, I broke the drawing. Whatever. So please do let me know if you have any questions with this. I guess we can do the second example real fast. So if you've already done that first example, that's awesome. I'll run through one more real quick, just because I said I would. All right, let's try this other one. Now this one's a little trickier because there's actually some more information here that you should know that I'm not giving you. So let's see if we can figure out. You have iron, and when I look up iron in the periodic table, we know that it's Fe. It's reacting in air, and air is not an element. Air's a bunch of stuff. So we'll have to look into that. We know that we're going to end up getting some black solid, Fe3O4. And the question is what on earth must we have combined the iron with? It doesn't tell us. Well, there's something in air that we think is pretty important that would probably be used to combine with iron here to make that O4. Yeah, probably oxygen. In fact, the same sort of oxygen that's right here. There's oxygen right now that you're breathing, this O2 stuff. So iron and O2 make Fe3O4. Now, I'll go fairly quickly on the balancing and stuff. Balancing's not too hard. Hey, look, 3 irons, we're going to need 3 irons. 4 oxygens, we're going to need 4 oxygens, which means we need 2 of those molecules to make that happen. As far as states go, we're not told. We're told this one. We're told that that one's a solid, but these other 2 we have to figure out for ourselves. Well, you're breathing this one. Pretty sure that this is a gas. This one, it's iron. It's like nails, things like that. Pretty sure that's a solid. I would expect you to know that. So I won't expect you to know some things, like I wouldn't expect you to necessarily know that NO2 is a gas. I would expect you to know that iron's a solid. All right, go ahead, work through these over the next few days. Like I said, due Thursday. If you do have any questions, drop by the Discord, send me an email. and we'll figure something out. I can help you out. I can work with you. We can do what we need to do. All right. All right, everyone. Stay safe and have a nice day.